Okay, so let's have a look at this histogram. So this histogram represents 100% of our data that we currently have. So when we look at our x-axis, we can see these are test scores. Now frequency would just be the amount of students. So in a situation where we see a frequency of 1, we know that one student got the range of 70 to 71. So considering this is a test score, we can safely assume that this would be 70. Okay? So what's the first thing we can do? Well, the first thing we can do is we can write down our data set just to make calculations a little bit easier. So we can see that one student got 70. The second group would be a frequency of 2, meaning 2 students got 71. 71. Then we have 172. We have no 73. We have a 74, 76, and 78. So these are the test scores. Now, if I count up all these values, this should be equal to my total frequency. So 1, 2, 3, 4, 5, 6, 7. So I have 7. My frequency, therefore, is 7. So let's see. We can count the top of these frequencies. So 1, 1, 1, 1, 1. So that's 2, 4, 5, 6, 7. So we are in fact correct. So one way to see what is my total population, which is the amount of people I got in this case to evaluate the test scores, is I can look at my total frequency. Okay, so I add the total frequency, and that should be equal to the number of people that took the test. Okay. So what's the first thing we can calculate? Well, we can calculate the mean. The mean is simply the average. So let's see. So the mean in this case is going to be, I can count all the sum of all my x values. So these are my x values. Okay. And I can divide that by my total frequency. Or we can say the sum of my x values times my frequency. Because in this case I have 2. So how would this look? It would look something like this. Well, we have 70 times 1 plus. We have 271, so that's 71 times 2 plus 72 times 1 plus 74 times 1 plus 76 times 1 plus 78 times 1. And we can place that over our total frequency. We know our frequency is 7. Let's go over to calculator. Okay, I'm going to grab my calculator. So 70 plus 71 plus 71 plus 72 plus 74 plus 76 plus 78. Okay, that gives me a total of 512 over 7. So my average is going to be 73.1428. So I'm just going to leave it as a fraction. So this will be my average, which is also known as the mean. Okay. So that's how we find the average. Now let's look at this data set again, and let's look at the mode. The mode is just the most frequent number. So in this case, we can just look at our frequency. We can see which one has the highest frequency. That will be my mode. So my highest frequency is 71. Okay, everything else is even. So if my mode, if this one was over here, if this was 1, I would have no mode because all of them are the same. But if this one was also a frequency of 2, I would then have 2 modes, which would be 71 and 74, if my frequency was a little bit higher. Okay. Next thing we can do is we can find the median. These are known as your central tendencies. Okay, so your 3 basic central tendencies that you're finding. So the median is just equal to the middle number. So let's cancel out 1, 2, 1, 2, 1, 2. So we can see my mean is going to be a sum of these 2 values. Now, let me quickly rewrite that just to make it a bit easier. I have 7 values, therefore if I have an odd number of data points, I will definitely have my median would definitely be one of the numbers. But if I have an even one, I need to plus the middle 2 numbers. So let's cancel out to find our middle number. And we see we have a median of 72. Now, how do we find this? Well, what you can simply do is you can take n. N would be the number of frequencies. So let's use f. Okay, so f is the frequency. We can plus 1 to our frequency, and we can divide that by 2. So let's see. So 7 plus 1 divided by 2. That gives me 8 divided by 2, which is then equal to 4. So then we can see, well, this is the first term, second term, third term, and the fourth term. So the fourth term is equal to this little formula, the frequency plus 1 divided by 2. Let's see if this is true for another case. We have, let's say we have 2, 4, 6. We know that the median is the middle number, so it will be 4. So let's see, the frequency plus 1 divided by 2. That's going to give me the frequency is 3 plus 1. So that gives me 4 divided by 2, which is 2. So first, second term. This does not work with even numbers, however. With even numbers, you can just say the frequency divided by 2, and you'll find some value between some different or two different values. Okay. Okay, I just want to clear. So now that we've calculated the median of 72, let's go find our quartiles. So quartile 1, quartile 2, and quartile 3. So we know that this one is our median, and our median is actually equal to quartile 2 as well. So we already have our second quartile, which is just the 50th percentile of the data. So when you have an odd data set, you want to divide it, okay, into two separate data sets. So here you have 3 to the left and 3 to the right. Now the median is the middle, or the Q1 is the median of the left side of your Q2, right? So if you have Q2, Q1 is the middle value of these points, and then Q3 is the middle value of these points. So let's go find. So Q1 is in fact 71. Hey, what did I do here? 72. And then if we work to the right hand side, we can see 76. So we have 76. And now we can find something that's known as the interquartile range, which is the difference between the cubes, or difference between the Qs, Q3 and Q1. So we have our interquartile range, which is simply going to be Q3 minus Q1. That gives me 76 minus 71. So therefore, we have an interquartile range of 5. One more thing we can see from this data points is we can find our range of our data set. Okay, our range. Our range is simply our maximum value minus our minimum value. Maximum value being 78, minimum value being 70. So we have a test score range of 8 points. Okay, now we found the central tendencies. Let's go over to something that's a little bit more complicated. In this case, we have our standard deviation. So our standard deviation is a very reliable way. It's just the average point from the mean, okay, when you spread out data. So we have our standard deviation. Now we can include a formula that includes the frequency. So you have this one where you have the frequency minus the x sub I minus mu squared over n, and you square root it. But I'm not going to focus on this formula for now. Let's focus on one that might be a little bit easier to understand, where you want to find the standard deviation. So the standard deviation is going to be every single point you subtract it from your average. Okay, so let's do this. Let's first write the skeleton of this equation. Okay, this is the skeleton. Plus, you take your next point, 71, minus 512 over 7 squared, plus, take your next point, 71 minus 512 over 7 squared plus, take your next point, and you just do this for every single point. Okay, so it's a lot easier to find this on Excel. I'm going to continue. So it's 74, 76, and 78. Okay, plus 74, 76, and 78, right? Okay, and we're going to divide this. We're going to divide all of this with our frequency. Our frequency is 7 people took the test, so you're going to divide it by 7. And to finalize this, you want to place this in a square root. Okay, let's hop over to our calculator. Okay, so it's very time consuming, I know. Yeah, usually when asked to find the standard deviation, they'll usually give you a very, very small amount of data points. But in this case, let's use the big one. So 71 squared plus 71. Now notice when you can take the frequency, multiply the x values, we can simply then say, well, the frequency times the sum of the x value plus. You can multiply it by 2. Okay? So whatever you find inside there, you can just multiply it by 2. It's a quicker way to do it. But I'll discuss that one another time. Just want to quickly run through minus the average. This is why I told you to leave the average as a fraction. Because if you didn't leave the average as a fraction, your standard deviation would be a little bit, wouldn't be as accurate as what it needs to be to measure data from the average point of the mean. Okay? So otherwise you had to put in, technically, you had to put in all those decimals. Sorry, I'm just typing on a calculator quick. This is taking forever, but it's okay. Okay, almost done. Plus 68 minus 512 over 7 squared. Okay, and we're going to place this over 7. Okay, so the standard deviation squared is equal, I did not place it in a square root yet, okay? I'm yet to place it in a square root. But here's where I want to make one point. So the standard deviation square is actually equal to your variance. So standard deviation and variance always come in the same type of question. They ask you, well, if the standard deviation is 4, what would the variance be? Well, the variance would just be 4 squared, so it's going to be 16. So this is the relationship between variance and standard deviation, that the standard deviation is the variance, or the variance is the standard deviation squared. So currently, this is my variance. So to find my standard deviation, I need to square root this value, okay? Since I want to square both, so my standard deviation, therefore, is the square root of 370 divided by 94. That gives me approximately 2.75. This is how we find standard deviation. Now you might be asked these type of questions where you have to analyze the histogram and then you need to decide information. So what was the highest test score average? Then you can say, well, the highest amount of students or the most amount of students got 71. Even though it's just 2, I took a very small data set. But these type of questions are usually they'll give you this histogram. Notice that a histogram is closely connected to one another. Okay? A bar chart is something that looks like this, where it has gaps in between. Even though there's gaps here, the gaps here means that no student got the score. Okay? So these gaps are supposed to be filled, but nobody got the score, so we don't add any bars in that. Back to my original point, my point was that these questions are very, very often asked with temperature. Okay, temperature. They love adding temperature to these type of equations or to these type of histograms. And then you need to be able to calculate all these different types of things, especially in the SATs. They love histograms. Okay, anyway.